Swayam Prabha. Digital India. Educated India.
So morning and welcome back. We're going to continue our discussion on voting, voting mechanisms. So let me just recall the setup that we stopped with yesterday, right? So we said that our input would typically consist of alternatives and voters and an expression of voter preferences over the alternatives. And these preferences could be expressed as rankings, and that's the usual, that's going to be our standard setup, but it could also be a bunch of other things such as approval ballots or rankings with ties or truncated lists or even just top candidates, right? So these are other ways of expressing preferences and we may encounter them later. The output, on the other hand, again, there are at least three natural things that you may want. So you may want a ranking over the candidates that reflects somehow the societal opinion over all the candidates, or you may want just a winning candidate or more generally a subset of winning candidates if you allow for ties, or you may be looking for a fixed sized committee for a particular task. Yeah, so these were the sorts of things that you might be looking for. And this was the general setup. So are there any questions? Is there anything that's not clear about this? Because this will be the basis for everything we do. Right. So in several situations, if you have a good mechanism for outputting a ranking, a committee may be something that you can obtain by just taking the top K from that ranking. But there are two reasons why you may want to consider this separately. First of all, if the size of the committee is much smaller than the total number of candidates, maybe you're doing too much work by trying to find a ranking of the entire set. And it may just be more efficient to directly find a small sized committee. And the other reason is that depending on your situation, you may not have any decent ranking mechanism. So when you weigh in the pros and cons of all the ranking mechanisms that you know, you may find that there's nothing that's really suitable for you. Maybe all of them have serious defects. But there may be a committee mechanism that's really so fine-tuned towards taking advantage of the fact that you're looking for a small-sized committee with no ranking between them, perhaps. Maybe there is something that works for you better than what any ranking mechanism would. But yeah, in general, you're right that one way of obtaining a committee is just to truncate a ranking. That's a fair point. Any other comments or questions? Okay. So we are going to begin by exploring some axiomatic considerations, which is to say that we will be looking at the picture of the class of voting mechanisms rather than analyzing them one by one. So as you can imagine, there are many, many voting mechanisms, right? Let's say we are interested in mechanisms that output a ranking based on a collection of rankings, okay? Again, just to be consistent with the handbook, here I've said that the output is a weak order, which means that in the output ranking we allow for ties, but that's a minor technicality and I wouldn't worry about it so much. How many mechanisms are there? If I asked you to count, how many mechanisms, so how many functions are there from the set of all profiles to the set of all rankings over candidates? So in general, if you have a function from a domain X to a range Y, how many functions are there from X to Y? Let's say that X has P elements and Y has Q elements. Yes? Q raised to power p, right? Is that the number of functions from x to y? Why would you say q raised to p? In some sense, you could think of it as having q options for every element in the domain, right? And so q options for the first element in the domain, q options for the second, and so on. And by the fundamental rule of counting, you multiply these options, and that's how you get q raised to p. Yeah? Okay, so what is the size of our domain? We are looking at functions that map profiles to rankings, right? How many profiles can you have? So let's say that the number of candidates, so I think I had it on the previous page, but I'll reiterate it. So let's say the number of candidates is m and the number of voters is n. How many profiles do we have? And what is the size of the domain that we are looking at? So how many rankings do we have over the candidates? So there are m candidates, and how many ways can you rank them? M factorial, right? And so that's the number of possible rankings. And each voter can potentially have any of these rankings as their personal preference. So how many profiles can you generate? M factorial raised to n, yeah. So that in some sense is our value of p, right? What is q? Q is the size of the range. So let's ignore the fact that we are looking at weak orders. Let's just say that we want to output a ranking. So again, how many rankings are there? It's m factorial, right? So that's the total number of voting mechanisms that exist, and that's a whole lot of them, okay? So analyzing them one by one is something that we would like to do. We would like to analyze some specific ones that we are able to come up with, but the axiomatic view is the following. We just look at the whole class of voting mechanisms and identify a property pi that we would really like the mechanism to satisfy. And then we ask ourselves, well, which are the voting mechanisms that satisfy the property versus which are the ones that don't, right? And there may be multiple properties that you are interested in, and you start asking questions like how many mechanisms satisfy all of these properties together, right? And we're going to see one or maybe even two concrete examples of statements which have this flavor. And the reason we are getting into this is basically to motivate the rest of what we will be looking at, which is a more computational viewpoint on these things. So let's consider a couple of properties that hopefully all of us will agree are very natural to demand from voting mechanisms. So the first one is what's known as Pareto. It's called the Paretian property, or you could think of it as unanimity, which is to say that if every voter has the same relative ordering over a given pair of candidates, then the output of the mechanism should respect that ordering. Yeah. So if everyone likes A over B, then the output should also rank A higher than B. So this is, we're not saying if the majority of the voters prefer A to B, or that if 99% of the voters prefer A over B. What we are saying is something fairly weak. We are saying that if everyone likes A over B, then the output should also respect it. Is that a reasonable thing to ask for, you think? Yeah, it's just saying that you should be minimally sensitive to the rankings of the voters. So this is the same thing, but in a sort of a pictorial form. Notice that the voters may prefer A over B greatly, or it may be a close thing for them, but nonetheless everybody likes A more than B. Okay? And then we are requesting that F should always output A over B. So that's the first property I want to consider. Here is the second one. This is a bit of a, so this slide is a bit crowded, sorry about that, but it's actually a simple concept. It's called independence of irrelevant alternatives, which basically says that the way your mechanism makes a decision between two candidates A and B should not be influenced by a third candidate which is different from A and B. Which is to say that if you look at two profiles, so let me just briefly switch to a pictorial depiction. So if you have two profiles where the relative ranking of the candidates A and B is exactly the same, it doesn't or it should not matter how the other candidates are ranked. The output of the mechanism should not be influenced by how the other candidates are ranked. Okay, so you say that a mechanism is independent of irrelevant alternatives if it has this property. So one way to remember IIA is this restaurant anecdote or comparison. So imagine that you are ordering dessert and you ask the waiter for options and they tell you that, well, they have gulab jamun and they have cake. Okay, and you say, okay, I prefer the cake, I'll take the cake. Okay. And then after a while he comes back and says, oh sorry, I forgot to tell you, we also have barfi. And then you say, oh okay, in that case I'll take the gulab jamun. That is a bit weird, right? I mean, the fact that there is barfi should not, it does not seem rational that you will switch from your original choice between gulab jamun and cake just because now there is barfi. You may want to switch to the barfi, that's a different story, but it should not influence your choice between the original desserts, right? So this is what independence of irrelevant alternatives tries to formalize. It's a little less universally accepted than unanimity as a desirable property, by which I mean that this is a property that is debated among social choice theorists. Some people think that this is indeed important, and some people feel that maybe this is not such a critical property to have. So we will talk more about whether this is a nice axiom to have or not, but for now let's just run with it. So hopefully the formal definition is also clear. What we are saying is that there are two profiles where the preference of every voter between two fixed candidates A and B is exactly the same. In this case, the output ranking should not change the way it relatively ranks A and B. That's what we are saying. Question? No. Yes, is the property clear? All right. So let's consider an adaptation of plurality to output a ranking. Okay, so this is where it's a little helpful that I'm allowing myself to output weak orders. So to adapt plurality to output a ranking, a natural thing to do is to rank candidates by their frequency of appearances in the top positions of the voters, right? So the candidate that makes the most frequent appearance is ranked first, and so on. And it's possible that there are two candidates who have the same frequency of appearance on the top. For instance, there may even be two candidates who are not the first choice for any voter at all, in which case they will both tie for the last position in the ranking. So is that clear? So is the mechanism clear? You just count how many times a candidate appears in the top positions of all the voters and you rank them highest frequency first and lowest frequency last. And there may be ties. So that's the weak order that you output. Okay. So this mechanism, do you think it is unanimous? So let's recall that unanimity requires that if every voter ranks A over B, then the mechanism should also rank A over B. Okay, so maybe I should be using Mentimeter for this. How many of you think that this mechanism is unanimous? Give me a show of hands. Believe it's unanimous? Okay. Those of you who don't think it is unanimous, is there an example? Yeah, so is there an example demonstrating that we violate unanimity by using this mechanism? Hmm. Hmm. So, right, so let's say we have somebody who is being ranked first most of the time, but there's one voter who is betraying A and you have a switch, okay? In this case, the output ranking is going to be A followed by B. And notice that here, one of the reasons that you would not violate unanimity is because the hypothesis does not even kick in, right? So the hypothesis for unanimity is that every voter should prefer A over B. Only then you have an obligation to do something on the output, right? But otherwise, it's fair game. You could have even ranked B over A and unanimity would not have complained. Okay, let's consider a situation where every candidate is ranked first by at least some voter, because it's related to the example that you brought up. So notice that this is not a natural assumption. It's not going to happen automatically. It is something that we are explicitly assuming. You may well have an election where there is a candidate who is not the favorite candidate for any voter, but who may nevertheless emerge as, say, a board account winner, because maybe the first position is contended heavily among several candidates, so the scores get distributed, whereas maybe the candidate who is never the favorite is ranked second by everybody. So such a candidate may still perform well under some mechanisms, and it's certainly not something that's automatically true for all profiles. But let's assume that we are considering profiles where every candidate is the favorite for at least one voter. For such profiles, is the plurality mechanism unanimous? So in particular, in such a profile, can you find a pair AB such that every voter ranks A ahead of B? This is the hypothesis for unanimity, right? And if every candidate is ranked first by somebody, is it possible that there are a pair of candidates for which the hypothesis of unanimity holds? No. Why not? Right. So is that clear? That if everyone appears on the top somewhere, and suppose it's the case that AB is uniformly ranked as A ahead of B by all the voters, then B never has a chance to come on the top, right? If B came on the top, then you would not have A is preferred over B. So the hypothesis for unanimity simply does not hold in this case, in which case the axiom is vacuously satisfied, right? Because you never need to check for anything, yes? But what if this is not the case? If it's not the case that every candidate is ranked first by someone, do we still satisfy unanimity? Yeah, so either you have a similar argument like the one we made here for why the axiom is satisfied, or you demonstrate an example where the axiom fails. Either one would be a valid answer to the question. So why don't you try to construct an example, and if you're not able to, then you might find you might discover a reasoning, or you might just be successful with an example. So can you come up with a collection of voters, all of whom rank A strictly over B, but the mechanism does not rank A strictly over B? When can this happen? So you should also try with at least 3 candidates, because clearly with 2 candidates, there is nothing to prove, right? I mean, either you are in this situation where both A and B have a chance at the top spot. Otherwise, if A is exclusively on the top spot, then the mechanism outputs A over B anyway. So you do need a third candidate if you want to come up with an example. How would you use the third candidate? So let's say everyone ranks A over B. What's a natural place to put the third candidate? Sorry? Oh, the question is to come up with an example that violates unanimity, if it exists. Yeah, so the condition would be that A is ranked above B by all the voters, but the mechanism does not rank A ahead of B. Sorry? It should satisfy unanimity. So let's just go back to the definition. Okay, so do we have an argument for why it satisfies unanimity? Sure. Sure. That is true. So if everyone ranks A ahead of B, it will never happen that your mechanism outputs B ahead of A. That is not possible, and that is straightforward to see if you just argue based on the counts, right? It would mean that, in fact, if A is ahead of B in all the votes, it's not even clear to me that B gets any first position votes at all, because A is ahead of B everywhere. So B's plurality score is certainly 0. So if A has any first position votes at all, A will be ranked strictly ahead of B. But otherwise, it's possible that A ends up having a tie with B. So that is the only slight violation of unanimity, because in unanimity we require that if A is ranked strictly ahead of B in all the votes, then the mechanism should also rank A strictly ahead of B. But what might happen is that A and B both get no first position chances at all, which means that the mechanism will put them in a tie, even though everybody said that I actually prefer A strictly over B. Okay. So it's a mild violation of unanimity in some sense, because you will at least never be in a situation where B is strictly ahead of A, but they may end up being in a tie. Right. So for the second case, let me just. So do you mean independence of irrelevant alternatives, or the situation that we were just talking about? The situation we were just talking about is this one. So here, notice that the new candidate C is the favorite for every voter. So the output of this mechanism is going to be C in the top place, and it doesn't know how to distinguish between A and B because it's only counting the first place votes. So if you only see the first place votes, you don't see A and B at all. So they both have a score of 0, and they end up being tied for the last place by the mechanism. So the mechanism is not cognizant of the fact that every voter actually did say that they prefer A strictly over B. So it's a small point, but you have a mild violation of unanimity by this example. So yeah, this was the mechanism. Remember, we said that you rank the alternatives in the order of frequency of their appearance at the top. And what we said was that you may have ties even for people who do come on the top. So it's possible that A and B are both liked at the top by 3 voters each, and C is liked by nobody. And if that's your entire profile, then A and B tie for the top position and C ties for the bottom position. Right? I mean, C is placed at the bottom. It does not have anyone to tie. Yeah, so is this clear? So you have a slight violation of unanimity, but in either when everyone has a first place vote, you actually do have unanimity, or you have a milder version of unanimity, which is that the ranking never gets flipped. What about independence of irrelevant alternatives? Does this mechanism respect independence of irrelevant alternatives? Can you either again come up with an argument or come up with an example which involves 2 profiles where every voter has the same relative ranking for A and B, but a third person is able to come and spoil the party, meaning that they're able to change the relative ordering of A and B. So this is a simple mechanism, so it should be possible to actually play with examples. So why don't you take 30 seconds to try and construct an example which violates IIA, or if the examples don't appear to work out, then do you have a sense of why the mechanism may actually satisfy this axiom? Sure. So do you want this version or this one? So this version says that, I mean, this is the formal definition, which says that if every voter in both profiles have the same relative ordering over A and B, then in both profiles, the mechanism should have the same relative order for A and B, should not change. So just to walk you through a concrete example, if the mechanism outputs A over B for the profile on the top, right, then it should output A over B for the other 2 profiles as well, because both the voters maintain their stance for A versus B. Although the positions have changed and the positions of the other candidates have also moved around, but that's the whole point of independence of irrelevant alternatives, which is to say that that movement does not affect the outcome. Yeah? So if we look at the first voter is always voting for A better than B. And if you look at the second voter is always voting for B greater than A, right, in all the profiles. So all of these profiles are in some sense the same as far as the relative position of A and B is concerned for every voter. So I am saying that if for the first profile F outputs A greater than B, then for example for these other profiles also F should output A greater than B. So if the mechanism F has committed to A greater than B for the first profile, then it should continue to maintain that for these other profiles as well. And in fact, you can generate many more profiles which have the same relative order for A and B with respect to these 2 voters. Is that clear, the definition of IIE? We are talking in terms of? Right, so the axiom is defined for any mechanism, but the question we are addressing right now is that the specific mechanism of plurality ranking, which is rank the voters in terms of the frequency of appearance in the top positions, does that mechanism satisfy this property? Yeah. So the property is defined in general for any mechanism that votes, that maps a collection of rankings to a weak order. Yeah. Sorry? It satisfies IIA. Is that the claim? That's what you feel. Okay. Is there anyone who wants to contest that with a counter example? Does not satisfy? Okay. So we have at least two responses which are contentious. So do you have an example? Okay, so let me just try and put that down here. So A in the first position, B in the second. So you have another agent that also does the same. Okay. Okay. Okay, I see. So, okay, so shall I just put in a third candidate here? See. Um, yeah, right, right. Yeah, I think that should account for it. Yes, thank you. So in this profile, in the current profile, the output is going to be A and C tying for the first position and B being placed at the bottom. Okay, so in particular, the output has A strictly ahead of B. However, if you end up swapping the positions of B and C in these two votes, which is to say that C got demoted by one place in these two votes, yes. Notice that the relative order of B and A did not change, right? So these two voters still prefer B over A, but now the gap between B and A has increased, that's all. However, this does change the outcome of the mechanism, because now you can see that the outcome is going to be B strictly preferred over A strictly preferred over C, because their scores are going to be 3, 2 and 0. Yeah. Is that clear? So this example shows that this mechanism in fact does not satisfy independence of irrelevant alternatives. And an exercise is to go back and check if the voting rules that we encountered yesterday, which is board account and co-planned, do they satisfy unanimity and do they satisfy independence of irrelevant alternatives? These are fairly fundamental properties. So any mechanism that you encounter, these are good first questions to ask. Is it Condorcet consistent? Is it unanimous? And so forth. Okay, so okay, so this was again another violation of IIA, but the spirit of the example is the same, so I'll skip it. Let's look at another voting rule, which is called dictatorship. It's a very simple voting rule. It simply says that the output of the mechanism will copy the preference of a particular voter. Okay, so what we are going to do is we are going to take the preferences of a fixed voter, let's say the kth voter, and we are just going to declare that to be the output of the mechanism. Okay, and such a voter is called a dictator. Okay. So what about dictatorship? Does it satisfy unanimity? So in some sense, this is a fairly trivial mechanism because it's not really doing any serious work with the entire profile. It's just lazily copying one of the preferences and presenting it as the output. Okay, it's always the preferences of a fixed voter. Yeah. So what about unanimity? If everyone votes for A over B, then in particular, the dictator has also voted for A over B, right? And therefore, the mechanism will also output A over B. Right? So the rule is unanimous, technically speaking. What about independence of irrelevant alternatives? So again, suppose you have two profiles that rank A and B in the same way, relatively speaking, for every voter, right? And suppose the first profile, in the first profile, the mechanism, so this is, the mechanism is fixed, we're looking at dictatorship. So let's just say that in the first profile, the kth voter prefers A over B. The reason I'm highlighting the preference of the kth voter is because the voting mechanism only depends on the vote of the kth voter, right? So suppose the kth voter prefers A over B, the mechanism is also going to output A over B, right? Because this is dictatorship that we are considering. In the other profile, we said that the relative preferences of A over B are the same for all the voters. And so again, in particular for the kth voter, the relative ordering of A and B is the same. And therefore, dictatorship will also output A over B in the second profile as well. Yeah. So these are not very satisfying arguments because they kind of go through trivially. Although the assumptions, the hypothesis is about the entire profile, we only needed to invoke it on a particular voter because that's how the mechanism is designed. So we have found a mechanism that does satisfy two very desirable properties, but we are probably not very excited about it because the mechanism doesn't really account for the profile at all. And a dictatorship is a sad sort of a voting rule to settle for. Yeah. So can you think of any other interesting mechanisms that satisfy these properties? So we saw that plurality does not cut it. And I encourage you to go back and sanity check Copeland and board account, but I can spoil it for you a little bit by saying that they both indeed violate independence of irrelevant alternatives, so those will not work either. So if anyone wants to exercise their imagination to come up with something that is slightly better than dictatorship, I'm setting a pretty low bar here in the sense that dictatorship is a really silly rule in some sense. Can we do better than dictatorship while respecting these properties? So I'm clearly not giving you enough time to think through this, but if you cannot find a mechanism, it's essentially not your fault because it turns out that the dictatorship is the only mechanism that actually enjoys these two properties when you're dealing with three or more candidates. Okay? And this is a result that is, at least to me, surprising and depressing in roughly equal measure. Okay, so literally this is the only mechanism that you would end up with if you insist on both of these properties. and if you're dealing with at least 3 alternatives. The dealing with 3 alternatives is a reasonable assumption because issues like independence of irrelevant alternatives don't even make sense when you're talking about 2 alternatives. So when you have only 2 alternatives, what do you think is a reasonable voting rule? Yeah, right. So plurality will, in fact, I mean, unless you have an even number of voters, plurality will emerge as majority when you have only 2 candidates. And it turns out that you can formally prove that that's actually the best thing to do, even in even from an axiomatic perspective. Okay, but here, once we move to the realm of 3 or more alternatives, which is the more interesting situation in some sense, we are really stuck with a dictatorship, at least to the extent that we are dealing with deterministic rules and so forth. Yeah. So this is in the context of welfare functions, which is the setting that we saw. You look at a collection of rankings and you are trying to output a weak order. Things may be different if you change the model and if you're not looking at preferences being expressed as rankings and so on. But for now, this is a fairly fundamental and cornerstone result, and it really inspired a lot of ideas thereafter. So this is one axiomatic result that I want to focus on in some detail, just to get a feel for how these arguments work. And we're going to see another result along similar lines, where I will probably not go over the proof in its complete we'll not go over the proof completely, but we will do it for a special case. But here, let's just try and understand what's going on. So we will in fact not need this notation, so let's just ignore it. Let's start off by considering any mechanism that satisfies these 2 properties. And what we will argue is, little by little, we will expose more and more properties of the mechanism, which will eventually lead us to the realization that this must indeed be a dictatorship and there is no other choice. That these 2 properties, in fact, restrain the mechanism to behave in a very specific way. So I'm going to skip ahead here. Okay, so So let me just drop a few things from this slide so that it's not so crowded. So let's first introduce this notion of a polarizing candidate. So a polarizing candidate is a candidate that is either ranked at the top or is ranked at the bottom for any voter. Okay, so it's an extreme candidate. People either love him or hate him. It's going to be like that for polarizing candidates. Yeah. And the claim is that if you have a mechanism which is IIA and unanimous, then in the output of the mechanism also, this candidate must be ranked either at the top or the bottom. Okay. So for the most part, I'm going to sort of show you a picture that involves only 3 candidates, A, B, and C. But you should be able to go back and convince yourself that this argument goes through in the presence of additional candidates as well, mostly because IIA allows you the flexibility to maneuver things around. So it should, I mean, if I have a chance to call it out later, I will. But here, yeah, let's just try and prove this claim here. So is the claim clear? If you have a polarizing candidate, then when the mechanism is applied to this profile, in the output ranking, B must be ranked first or last, if B is the polarizing candidate. Okay. Is the statement clear? Yeah? Okay. So let's try and argue this by contradiction. So we are going to start off by saying, suppose this is not the case. So the mechanism, so the candidate is polarizing, but the mechanism does not place it at the top or the bottom place in its output ranking, which means that the mechanism places it somewhere in the middle. And so there's at least one candidate that is ranked above B, and there's at least one candidate that's ranked below B. Yes? Okay, so by staring at A, B, and C, can you drive some sort of a contradiction by exploiting IIA and unanimity? Sorry? So for every voter, so do you want to change the positions of B in the voters, or no, that's not what you're saying? Okay, so if A is ahead of, okay, so if B is in the middle in the output, then B must be in the middle for some voter. That's what you're suggesting. That is perhaps true, but it's not completely obvious to me as to why that is the case. I mean, that is something that will be implied by this result, but yeah, but I still think it needs an argument. So remember that the tools that you have at hand are IIA and unanimity. You know that your mechanism satisfies these two properties. So you really have to take advantage of that to drive a contradiction. Correct. So currently it is not unanimous because, I mean, the profile on the left is not unanimous for any pair of voters, I think, because between B and C, you get a difference because it's polarizing both ways, right? And between A and C, you can see that there are voters who rank A and C differently. So there are three pairs and it's not unanimous for any pair at the moment. But I'm still suggesting that we should use unanimity and we should also use IIA. So maybe one suggestion is that you are welcome to modify the profile. You can modify the profile and try and understand what is the impact of the modification based on the fact that the mechanism is required to satisfy these properties, right? Um, Sorry, so for the first three voters, A is in the second, third and second positions respectively. Right. Right. So let's try to make this change where we say, okay, here in the second vote, let's try to put A in the second position. And in the last vote also, let's do the same. Let's try and put A in the second position. In the top position. Basically, we upgraded A in both of these votes. Yeah. So this is now a new profile, and so in the original profile, the output was A followed by B followed by C. In this new profile, what we know is that I think you have modified the profile with the goal of being able to use unanimity, because what you have done is you have made sure that everybody ranks A and C in the same way. So in this profile, although I don't know the details of what the mechanism is going to output, I do know that because of unanimity, the mechanism is forced to output A ahead of C. Yeah. So this is along the correct lines, but in the original profile also okay, so So how does this lead us to a contradiction? Okay, using IIA also, I know that the relative ordering between A and B must be the same, and the relative ordering between B and C must also be the same, because notice that we did not change anything between B and A or B and C. So the positions of B were fixed. Whatever we changed happened in the middle. And so we can use IIA for the pairs BA and BC. Yeah. So we also know that by applying IIA, we know that this new profile must rank A ahead of B and B ahead of C. Because in the old profile, that's what it was doing. Remember, that was our assumption here. So we know that that's what is going on here. So it must respect the same relative ordering. But now A to B to C is a pretty feasible outcome. So we're not getting a contradiction just yet. But a small tweak to this argument will lead you to a contradiction. So, right. Right. So that is, yeah, so that is certainly one approach which I'm just going to come back to and discuss. Are there any other suggestions from anyone? So you're getting the hang of the game that we are playing here, right? We are trying to modify the profile in such a way that, so we know certain things about what the profile is doing on the, what the mechanism is doing on the original profile, right? Based on what we assumed for the sake of contradiction. So on the original profile, we said that, okay, so B is not being ranked at the top or the bottom, so it must be ranked in the middle. So we know for sure that the mechanism has output a ranking where there is some candidate ranked above B and some candidate ranked below B. And we gave them these names A and C respectively. And now we're saying, okay, so let's go back to the profile and see if we can make some changes. And let's see if we can still understand what the mechanism will do on this modified profile based on what it was doing on the original profile, with the understanding that it must respect unanimity and IIA. That's kind of what we are trying to do here. So I think the original suggestion was really close, except that instead of changing CA to AC, let's change AC to CA, because that will force the mechanism to do something that's opposite to what it was doing before. But because of IIA, it's still constrained to respect B sitting in the middle of A and C. But by unanimity, it must rank C ahead of A. And that is your contradiction. Yeah. So I should have this on the next page. Let me just check. Right. So if we do this, if we change all the voters to place C ahead of A, then because of unanimity, you are forced to place C ahead of A. But by independence of irrelevant alternatives, you are still stuck with sandwiching B between A and C. So A must appear ahead of B and B must appear ahead of C, which prevents you from being able to rank C ahead of A. Okay, but unanimity is still requesting you to rank C ahead of A. So you cannot satisfy both of these properties. Okay, so one of them will end up complaining no matter what you do, right? Which is a contradiction to the assumption that the mechanism in fact was a mechanism that satisfied both properties. Yeah. So this is a small lemma. Is the argument clear, or are there any questions? Sorry? So where did we use IIA? Is that the question? How did it play a role in the argument? IIA, is that the question? Okay, so here, once we made these modifications to the profile, notice that we know that by unanimity C must be, we know that by unanimity C must be ranked ahead of A, right, in this new profile. However, compare the new profile to the old one. In the old one, so we have not changed the positions of B at all as we modified the profile, which means that the relative ordering of B and C as well as B and A are exactly the same. And what you see on the right here is the output of the mechanism on the old profile, which we assumed for contradiction, right. So, we said that A is ranked ahead of B and B is ranked ahead of C for the sake of contradiction. That's what happens when B turns up in the middle. So, we know that in the new profile as well, A must be ahead of B in the output of the mechanism and B must be ahead of C in the output of the mechanism by IIA, because B and A and B and C, their relative orderings did not change for any of the voters the way we have modified the votes. We only played around with the relative orderings of A and C, and that also we did strategically to be able to get the unanimity condition, forcing the mechanism to output C over A. But by IIA, the mechanism is also forced to output A over B and B over C, and that is something that cannot be simultaneously realized. Yeah. Okay, so this leads us to the notion of a B pivotal voter, which is a voter who is capable of swinging the outcome for B by just changing her vote alone. Okay, so let me just try to walk you through the definition. So a voter B is called B pivotal or pivotal for the candidate B if there is a profile where B is polarizing and B is ranked at the top in that profile. Okay, and so when I say B is ranked at the top in the profile, I mean when the mechanism is applied to the profile, when F is applied to the profile, in the output ranking B comes out on the top. Okay, and if there is another profile which is the same as this one except for the vote of the voter B, where B gets demoted to the bottom in the output of the mechanism, then this voter is called B pivotal. So essentially you started with one profile where B was polarizing and the mechanism was placing B at the top, okay, and the voter B had the candidate B either at the top or the bottom, and let's say that the voter B decided to switch to, let's say, having B at the top to having B at the bottom, then the mechanism's output actually changed from having B at the top to B at the bottom, which means that this voter is very, very influential for the fate of the candidate B. By just changing her vote, she was able to persuade the mechanism into changing the outcome for B. Yeah, that is the notion of a B pivotal voter. It's not clear why a B pivotal voter should even exist, but at least hopefully the notion is clear. So the picture here is essentially a picture of the profile which we have divided into two parts. So let's say that the green blob represents all the voters who rank B at the top, and the red blob represents all the voters who rank B at the bottom. And there are no other voters because the profile is polarizing for B, right. So every voter either ranks B at the top or B at the bottom. That's what it means for the profile to be polarizing, right. So since we are dealing with an abstract mechanism about which we really know nothing, the parity of the number of voters does not immediately come into play. But maybe let's go through the rest of the argument and you could let me know if you spot a place where you see the parity being important. As far as I remember, it doesn't play a role in this argument, but we will see. So for the definition, all that we are saying is that a voter is pivotal for B if there is a situation where if the voter migrates from the set N1 to N2, which is that the voter goes from placing B at the top to placing B at the bottom, the output of the mechanism changes from placing B at the top to B at the bottom. Okay. So we already know that because this is a polarizing profile, in the mechanism I mean, when you apply F to this profile, B is either at the top or the bottom, right? So let's say that you had a profile where B was on the top, and let's say you now have a new profile where B changes her mind and says that, okay, I'm not going to place B on the top, I'm going to place B at the bottom. And if she does that, what happens is that the mechanism also ends up placing B at the bottom, okay? So even if there were 1,000 other voters who were voting for B being at the top, just losing the voter V from his camp caused B to drop all the way to the bottom, okay? Which means that in some sense this voter is special for B. Her opinion matters for how the mechanism treats B. Yeah? It's just a notion at the moment. We haven't really said that, you know, we can always find such voters, but that's what we are going to argue next. We're going to say that there is, in fact, for every candidate, there is a pivotal voter. And eventually, roughly what we are going to say is that the pivotal voters for all the candidates are in fact the same voter, and that voter is the voter that will emerge as the dictator. Which, if you recall, was our original goal. Our original goal was to say that if the mechanism satisfies these two innocent looking properties, which is IIA and unanimity, then it must in fact be dictatorial, right?